This video covers the second day of section 8.5. We are going to learn how to calculate a determinant of a 3 by 3 matrix, and then I'm going to show you where we can use 3 by 3 determinants with application problems. So the first part is the notation. You can either have DET written in front of your matrix that you're calculating the determinant of, or you can have the 3 by 3 matrix surrounded by these vertical bars, and that also indicates that you are supposed to calculate the determinant. So just note that these are not the same thing as absolute value bars. That is with numbers and your distance from 0 on the number line, and so that does not represent the same meaning with matrices. So these vertical bars mean to calculate the determinant. So I'm going to break this up into 3 little pieces. It's going to look a little overwhelming at first, but I promise you that it's just a bunch of 2 by 2 matrices. So what I like to do first is, only looking at the top row, A, B, C, what I would normally do is circle the A, and then if you kind of imagine a line going underneath A, like crossing out D and G, and then going to the right of A and crossing out B and C, what you're left with is a 2 by 2 matrix, E, F, H, and I. And so you'll calculate the 2 by 2 matrix determinant and then multiply it by A. The next part would be to circle your B value, and then when you're showing your work, you always take the opposite of B. So if B is positive, you make it negative. If B is negative, you make it positive. And then imagine if you were to cross out the letters below B or to the left and right, you are left with the values that are in the place of D, F, G, and I. So you calculate that 2 by 2 determinant, and then you multiply it by B. And then the last step, just kind of following with that pattern, if you were to circle C, cross out a line, or have a line below C and to the left of C, you're left with D, E, G, and H. So the example that I have here is a 3 by 3 matrix, 5, 4, negative 3, 7, negative 2, 4, and 3, 2, negative 1. So I'm going to go piece by piece with what I do to solve these by hand. So the very first thing I did, I usually circle my top left value and then I cross out the numbers. You don't want to cross them out so that you can't read them because you'll need them for the next steps, but you can still read what they are. So 5, and so I'm going to write my 5 there. And then the 2 by 2 matrix that is left is negative 2, 4, 2, and negative 1. I'm going to calculate this all a little bit later, but then the next part would be to circle the 4, that's the middle number, and then cross out the numbers below and then to the left and the right. And so now you have minus 4, so remember to always take the opposite of whatever that middle number is. So negative 4 times the determinant of 7, 4, 3, and negative 1. That's the 2 by 2 matrix that's left over after you've crossed the other numbers out. And then the last piece is circling the negative 3. You're going to keep that as a negative, cross out the numbers to the left and below it, and then find the 2 by 2 matrix, 7, negative 2, 3, 2, calculate that determinant, and multiply it by negative 3. And so what you end up with, negative 2 times negative 1 is a positive 2, 2 times 4 is 8, 2 minus 8 is negative 6. Then you have 7 times a negative 1, which is negative 7, minus 3 times 4 is 12, so that would be negative 19. And then 7 times 2 is 14, minus a negative 6. You end up with a positive 20. When you multiply these numbers together and add them together, you end up with negative 14. You should be able to do these by hand. We'll try and keep the numbers smaller than normal so that you guys can do the calculations without a calculator. Determinants of 3 by 3 matrices are used in many application problems, but we are going to use them to solve the area of a triangle with 3 vertices in the coordinate plane. So if you're given the vertices x, y, x, y, x, y, I just numbered them so that you know that there were 3 of them. The formula for it is plus or minus 1/2 times, and you write whatever coordinate you want in the top row, and then the last column is always 1. So we have x1, y1, 1, x2, y2, 1, and x3, y3, 1. Order doesn't matter, you'll end up with the exact same area. The reason the formula has a plus or minus at the front is because the determinant can come out to be a negative value, but area can't be a negative number. So you would use a negative 1/2 if your determinant is a negative value, but if it's positive, then you just multiply it by a positive 1/2. So if you think about the area formula of a triangle from geometry, it was 1/2 times the height times the base. What this 3x3 determinant does is it gives you the product of the height times the base of the triangle. And so then the last thing you do is multiply it by 1/2. So the example that I have here is called the Golden Triangle, and it refers to a large region in India, and it is created by these three cities, New Delhi, Agra, and Jaipur, and the Taj Mahal does fall somewhere in the Golden Triangle. And so here's the little picture that you have of the coordinates. Each tick mark represents 20 miles, but the coordinates are already given to you in that nature. And so my suggestion when you guys are using 3x3 determinants and you're given coordinates, anytime you're given a coordinate that has a 0 in it, go ahead and put that in the top row. And the reason for that is because it reduces your workload, because then you're multiplying a 2x2 determinant with a 0 and that just goes away. And so since you have 0, 0 as one of the coordinates, put that in your top row. Then you have 100, 120, and then a 1 in the third column, and then 140, 20, and 1. When you write out the determinants using the 3x3 formula that we learned up above, I don't have to worry about the ones with the zeros because those are just going to go away. And so what I'm going to multiply by, I would circle this 1, which is just going to be 1, and the 2x2 that's left over is 100, 120, 140, and 20. And so what that looks like is 100 times 20 minus 120 times 140. Now this is one where you could use a calculator if you couldn't do that math in your head. And you always do the determinant first, so don't multiply anything by 1/2 till the very end. So then you get, I'm going to use a negative 1/2 times negative 14,800. So because this came out to be a negative value, I want to multiply it by a negative 1/2 so that my area is a positive 7,400 square miles. So that is the area of the Golden Triangle in India. So what you're going to do for the rest of the hour is complete the group work from yesterday, hand that in, and then you can work on the assignment when you are all done. Have a good day.